This is a short screencast to go over writing energy chains, which is something that you've just started doing. And we're going to use some of the examples of Coyote and the Roadrunner. So a few sessions ago I actually talked to you about Coyote pulling himself into a stretched rubber band so that he could shoot past and catch up with Roadrunner and catch him. So the very first thing we have to think of is, what's he starting with here? He's pulling himself into a rubber band and he's stretching himself. Now as soon as I say rubber band and stretching, you're going to think elastic potential energy, and you'd be right. That's definitely one of the energies that we're going to be looking at here. We're going to shorten that to EPE. We could also think about the other energies that came into play before he stretched the rubber band out. Where did he get the energy to stretch that rubber band? When he was actually stretching it, was he moving it? If he stretched it, he moved it, which means he had some kinetic energy there, motion energy. So we've got another lot of energy that comes into play there. Now when you think, when he stretched it and pulled it, where did he get the energy to put that kinetic energy in and stretch it? Well, if you take another step back, he actually would have got that energy from his food. So to actually do that, he had to have had food in the morning that his body could burn, which would be chemical potential energy, in order to stretch out the elastic band, in order to give it potential energy, in order to push himself past Roadrunner. So, think. Let's start at the very beginning. We're going to go right back to the start, and the very start was the food he ate that morning. That's the beginning of all of this. He started with some chemical potential energy, and he used that to stretch out that rubber band. So when he stretched it, he moved it, and that was motion kinetic energy. So that was stretching the rubber band. And then he had to go a little bit further. When he stretched it out, he gave the elastic band elastic potential energy. So when he stretches it, he turns kinetic energy into elastic potential energy. Now that he's got that elastic potential energy, he's going to let that go so he flies through the air, and that will turn again into kinetic energy of motion. So we have here a chain of energy transformations and transferals. Okay, so now we've got this energy chain, and it's not as simple as we first thought. You have to start right from the beginning, from the energy that you get to do something, to put potential into something, to do something else. And this is how most actions and activities work. Now, when you think about it, not all of the energy from his food in the morning went into stretching that rubber band. When you stretch something out or you do exercise, you'll notice that you get quite hot and sweaty, and it means that you are losing some energy in the form of heat, usually heat and sound. Because as you're stretching that rubber band, do you hear it stretching out, and do you hear it making a sound? That is some of that chemical potential energy being lost in the form of sound waves. So what originally was a large amount of energy up here has now had some of its energy depleted, and only part of that energy is put into the next action, which was the kinetic energy of motion pulling the elastic band apart. And again, once you've got that energy there, you've given that elastic band potential to push something through the air, but as it converts back from kinetic energy into elastic potential energy, again you're going to have some losses as you transform or transfer something. Every time you have a transfer or transformation, you have some energy lost. Always in the form of heat, because you always usually have two surfaces rubbing together, which is friction. And every time you have friction, you have some heat produced, and that's how the energy is wasted and essentially taken out of the system. Because heat is fine, we love heat, but does it help us fly the Coyote through the air? No, it doesn't. So essentially that energy there is now lost to him. So every time you have any two surfaces rubbing together, any friction, you have heat loss, you have some wasted energy. And that is an energy chain. Now I could also depict it like this, which is a harder version to write, but basically it depicts that the energy is actually getting less and less as it's losing energy along the side here. So as energy is wasted, the amount of energy that's actually transferred or transformed in the system gets less each time you go along. So this is just a picture version that shows the wasted energy and the amount of wasted energy in that system. But all of the rest of this stays the same. It still loses energy in the form of heat and sound. It's just a picture version of how much energy is left after each of those transfers or transformations.